All right, so today what we're going to do is we're going to look at our second type of equations. The first type of equation that we looked at were linear equations, and we could tell they were linear because they did not have any exponents at all. Yes? We also looked at linear inequations as well. So today what we're going to do is we're going to look at the second type of equation, which is probably the most common type of equation, especially for this course. Now you've seen them before. If you haven't, don't worry about it. I'm going to treat it as if you have not. So it's quite easy because you know how to factor. If you can factor, you can solve quadratic equations. So first of all, we're going to talk about what makes the equation and then write down the steps. So how do you know that something is quadratic? The highest exponent or index, whichever you prefer, is a 2. Also known as square, and a square is a type of quadrilateral, right? So that's where quadratic comes from. You'll notice that most things in algebra, strangely enough, are named after geometry. All right. So if you see that the highest exponent is a 2, or you see that if you multiply out some brackets, you would end up with a square, then you know you have a quadratic equation. And we're going to do a lot of work with the quadratic equations, but the first and most basic idea is how to solve them. Now, I'm going to write down some steps for solving these quadratic equations. Oh, first of all, so that's the second part. How do you know that something is an equation? Yes, it has an equal symbol. Good. So, not everything is an equation, right? So don't get carried away and try to solve things that you're not allowed to solve. Okay. So what we're going to do is we're going to talk about the processes for these. Then we're going to talk about one that's kind of a special case that you need to be aware of. Right. So just as with any other equation, the first 3 steps are always there. It doesn't matter what kind of equation you're solving. Remember, those first 3 steps are designed to clean up the equation and get it ready to solve. And the first thing you look for are brackets. Now, put a little note. Most of the time. And I'll explain what I mean by that. Some of the problems that they give you, they try to make your life easier by having it factorized for you before you is already. So they've already done one of the steps, which, remember, when you factorize something, you introduce sets of brackets, yeah? And so you need to see, are the brackets just brackets, meaning operation symbols, or are the brackets there because it's already been factored for you? In trying to make your life easier, they really actually make it much more difficult because your brackets end up having 2 meanings. Now we're going to look at examples of both, and I'm going to show you how you know the difference. But generally, if you have a bracket and another bracket and it equals 0, that means you don't need to eliminate the brackets. They've already factorized it for you. But bracket and another bracket equals anything other than 0, then you must clear the brackets first. You see the difference? So you know that it's already factored for you because it already equals what number? 0. Good. But if it equals anything else, then you have to clear the brackets. All right.
Is that like a general rule?
For quadratics, yeah. Or anything bigger. Anything that you would generally solve by using factoring. Mm-hmm. Yes. So if you see that, if you said equals 0 in its brackets, that means they've done half the work for you. You're good to go. But if it doesn't equal 0 and you have brackets, that means you have to clear the brackets first. Yes. Absolutely. It's going to be the same for any higher degree equation. All right. Second step. Clear fractions. Now we looked at some fractions yesterday, simplifying them. We're going to be doing a lot of work with quadratic fractions as we move forward. Clearing fractions, though, uses the same process for linear as it is for quadratics, as it is for any other type. To clear the fractions, we're simply going to first find the LCD, and then we're going to multiply every single term by that LCD. Now, the only difference is that with quadratics, the fractions are bigger than they are with linears. Because remember, with quadratics, you generally have more terms in the when you factorize things or in the denominators, etc. So you're just going to see they get bigger. But the process is exactly the same. And we can still use that upside down division symbol business that I taught you at the very beginning of the year to be able to find the LCD. Now, you don't have to. You can do it any way you want to, but I'm going to show it to you so that you can have some method. And the third and final step for cleaning it up is always to combine like terms. Do you remember where? Good job. On the same side. Remember, we're not moving anything around yet. All we're doing is cleaning it up, getting it ready to solve. So you make sure that you're not combining things that are on opposite sides of the equal symbol. That'll cause you trouble. We're just going to look at the right-hand side, then look at the left-hand side, or whatever order you want to, and see if there's any cleaning up you can do, combining like terms. Fairly rare, but if you multiplied out some brackets, remember there are generally like terms when you do that. Okay? Now, once you've done that, okay, once you've cleaned it up using those steps, now we're ready to start solving. Okay? So to solve, first, we need to factor completely. You will never hear me say, oops, can't spell completely. Well, you will, unless it's an accident. I generally don't say just factor. I always say factor completely. Because if you take the time to add that extra word of completely, it might clue you into the most common mistake in factorizing, which is forgetting to take out the GCF. Yeah. So factor completely. If you get used to saying factorize, I'm sorry, guys. So factorize completely, then it'll trigger, right, that there's more to do. So everybody wants to just jump straight in without taking out that GCF first. So be careful. All right. Second step. After you have it completely, what you're going to do... Hold on. I've already made a horrible mistake. Put that as 2. Hopefully you left a little room. Sorry. Let me try that once more. Yeah. Set the equation equal to 0. Kind of critical. It's a terrible morning. Okay, set the equation equal to 0. In other words, I need every possible term on one side of the equal symbol. Doesn't matter which side, right or left, doesn't make the slightest bit of difference, but you need to have every non-zero term on one side and on the other side have just a plain old 0. Because we need to have every term on one side in order to be able to factorize it. Okay? So factoring will be the second step. Sorry about that. Third step is you're going to set each factor equal to 0. Now, when you do this, there's no math involved here. You're just going to take each bracket and put a 0, put equal 0. Because if you think about it, those brackets mean we're multiplying things together. And the only way to multiply things together and get a 0 is if one of them or both of them is a 0. So that means that each bracket has the potential to equal 0. So you're just going to put equal 0 for them. Okay? Now, when you do that, you can also eliminate the brackets. Because the only reason the brackets are there is to show you one thing multiplied times something else. Well, if you separate them, they're no longer multiplied together, right? So you can also drop the bracket. But just take each factor and set it equal to 0. Again, don't do any math there. Then, you no longer have one quadratic equation, but 2 linear ones. In other words, the highest exponent now, because when you factorize something, the highest exponent you're ever going to get, if it's properly factorized, is a 1. Okay? So you're no longer going to have one quadratic, but two linear. So what you want to do is solve the two linear equations using the process that we've already talked about. Now, if I solve two linear equations, how many answers do I expect to get? Two. So I've turned something with one equation into two equations, so that means I'm going to get two answers most of the time. Mm-hmm.
Is this the same, like solving them at once, like the simultaneous equation?
Not exactly, because that's two different equations, right? We're breaking one equation into two.
But when you solve the linear equations, is it?
No, because you're not solving them together at the same time. We're going to separate them out, solve this one, then solve that one. Whereas with simultaneous equations, we're going to add them together to be able to solve them at the same time. Okay? Slightly different. But we'll get there. That's on the test too. All right. Solve the two linear equations. Now, you will get two answers. Unless the solutions are the same number. So if you got x equals 2 and x equals 2, you would only write down x equals 2, which is going to mess with you later. Because in reality, how many 2's are there? 2. But since they're both 2, we only write it down once. I don't know why. Because later, I'm going to tell you, you need both of them. But for the solution, if it's just a straight equation, you only need one. But when you're graphing them later, you're going to need to recognize that there are two of them. Okay? Yes?
Do they mark you down if you just put both of them?
They could. When it's an equation, you should only write, if there's one solution, you should only write one solution. Okay? Now, in your working, you can show both of them, but then you need to go ahead and say, so x is equal to 2, because it really means x is equal to 2 under any circumstances, right? So it doesn't matter. So that's what they're doing. But then later, they want you need to know that there are really two of them. Because do you remember what happens when you graph something when there are two numbers that are identical? It doesn't cross the x-axis. What it does is it bounces off. And the only reason you get that bounce is because there are two of the same number? No? Okay, never mind. Don't worry, you'll know it soon. Okay. All right. So there you go. Those are their steps to solve it. So most of the work is in the factorizing. After you have it factorized, then it's just set each one equal to 0 and solve. And you don't need to show all of that if you don't have to. If I have x plus 2, I know that I'm going to end up subtracting 2, so x is equal to negative 2. You're just going to get the opposite as long as your x is by itself, right? But you need to be careful. If you try to do too much stuff in your head and you have something like 4x minus 3, the tendency is to forget the 4. So be very careful. You write down as much as you need to be sure that you're getting the right answer. I know all of you are pretty strong students. That does not mean you can't make simple mistakes by trying to take too many shortcuts. That is what you need to be sure to avoid, not just on the MCAT, but just in mathematics in general, right? That's the most common mistake. You're going along fine, you say, I've got this pattern, I see what's happening, then something different comes along, and boom, you don't see what's happening. Okay? Yes?
Just one last thing. I'm pretty sure. So if you get two answers and it's x equals 2 and x equals negative 2,
Mm-hmm.
are they two different answers?
Yes, they're two distinct answers. So you're just going to write x equals and then put them in a list. You just separate them with a comma. So that'd be two distinct answers. Mm-hmm. Of course you may. All right, and so that just and you'll see why they're so important when we start graphing them. Okay. All right. Now, this is just straight quadratic equations. We're not talking about applications with quadratic equations because that throws a whole other wrinkle in it. Because say we were doing a quadratic equation and we were talking about money and we got 5 and negative 2. What do you know about money? It's not going to be negative, right? Okay, so you're going to see that you're going to have to reject some of those answers. So you have to be prepared to look at your answers and really understand what's being asked of you. But again, when you're just solving the equation, we're not going to reject anything. But when you're looking at applications later, so lots of things can happen to you. Again, quadratics are the biggest part of this course. All right. Now, so first I want to show you just an example of something that is already factored for you. I hate these. They make me crazy because I always end up multiplying out the brackets and then going, I didn't have to do that. Right? But if you do, you know how it's factored. You just go right back to what you started with. So say you have something like x plus 2 times 3x minus 1 in brackets equals 0. Now, this one is already factorized for me. I do not want to multiply out those brackets. Can anybody tell me how I can tell that? Yes? Because it already equals 0. Exactly. Okay? So if it wasn't equal to 0, let's say it was equal to 2, is that already factored for me? No, those are actual brackets that I need to expand. Remember that word expand always goes with brackets. So in that case, I would have to expand it and then set it equal to 0. But in this case, it's already set equal to 0 for me. It's already got the brackets. It's done. It's ready to go. So all I need to do is set each one of those brackets equal to what? 0. So I've got x plus 2 equals 0, and I have 3x minus 1 equals 0. I don't need the brackets anymore because they're not multiplied together. That was the whole point of the brackets. And since they're not multiplied, you don't need the brackets anymore. Oops, sorry. Now, what we'll do is simply solve, because now I no longer have one quadratic, but two linear equations. Good. So I'm going to solve them by doing the opposite. Now, you know that I'm going to show you every step. You can do as much of this in your head as you want to. But again, the most common error is not knowing not knowing what you know, what you need. It's making simple mistakes because you try to do too much in your head. So be careful. If you know who you are, right? If you're like me, write them down. Some of you can just see it, and it's perfectly fine. Okay, no one's going to be looking that you did all of the steps. So we're going to subtract 2 from the first one from both sides to get that x by itself. Gives you x equals negative 2. On this side, we need to add the 1. Gives us 3x equals 1. And then, since that's connected with multiplication, we'll take it apart by dividing. Gives us x equals 1 over 3. Many of your answers will be fractions. And you know that if you have a coefficient in front of your x, unless it divides evenly away, it will always end with a fraction. Right? Okay? So those are my two answers. So x is equal to negative 2 and positive 1/3. In no particular order, I don't care. Right? Pretty straightforward. So when they're like that, they're really doing you a favor, but they're testing your ability to recognize that part of the work has already been done for you. They love to do that. They'll get it started for you and say, okay, now finish it. Right? So be aware that if you do a lot of stuff in your head, you may not be able to recognize where they are, right, in the process. So they may ask you, they may have some of it done, and then they'll say, what would be the next step in the process? And they don't want you to actually write it out. They want you to do it, right? So you need to be aware of every part of the process, yeah? They may also do stuff without writing it down and say what would be the next thing. You see what I'm saying? So they may do something in their head and then want you to anticipate the next move. Yes?
I'm confused about why you put 3x over 3.
Because it's 3 times x, right? 3x means 3 times x. And the opposite of multiply by 3 is divide by 3, right? We're using the opposite operation. Look at how things are put together and take them apart by doing the opposite. So if you had like 4x equals 0, that's 4 times x. So to get that x by itself, I need to divide both sides by 4. So that gets me my x by itself, right? So anytime you have a number in front of the x, it's a coefficient, it's a multiplier, so you always divide by whatever that number is. And that brings me to something else. Be careful if it's a negative. Now, when you factorize something, your x is never going to be negative, but it could happen. Say it was negative 3x equals 2. I need to divide by not just the 3, but I need the negative and the 3 to divide away, right? So be careful with that if you have a sign. Now, again, when you factorize something, you're never going to have a negative x there. But if it's already factorized for you, it could happen. Okay? All right. What if I have 15x squared minus 14x minus 8 equals 0? Let's make it, we'll go ahead and stick with it. It's fine. Sometimes they've already done some of the work for you, and in this case, they have. What have they already done for you? Set it equal to 0, right? So there are no brackets, there are no fractions, there are no like terms on this side. There's nothing on the other side but 0. So we need to know what kind of equation is it. What's the biggest exponent you see up there? A 2, which makes this a quadratic equation. To solve a quadratic equation, the first step is to set it equal to 0. All right? What do you notice? It's already set equal to 0, right? That just means every term is on one side, 0 on the other.
So do you just put equals 0?
No. I'll show you. We'll look at one that's not. You actually have to move it using the rules, which is do the opposite, right? Okay? Now, so we have it set equal to 0. The next step is to factor it. This one is not easy to factor. That's why I chose it. So, first thing we look for is a GCF. HCF. Is that what they call it? The highest common here instead of a greatest common? Oh, well, bummer. Okay, nobody ever told me that. Okay, HCF, GCF, whichever you prefer. Which would you like me to say?
H.
H? Okay, as long as it's H and not H. Sorry, I have a New Zealand prejudice. Highest. Anyway. Okay, next. Now, see? Okay, here we go. Now, so we're going to factorize it. Is there an HCF or a GCF? No. So, how many terms is that? 3. So we're going to use the AC method. So what is my A in this case? 15 times what is my C? Negative 8. Yeah, so big numbers. So negative 15 times negative 8 is negative. Yes.
Why do you not take the x squared with it? You've got minus.
Because remember, when you're doing the AC method, all you need is the numbers.
Why don't you have the x?
That's a multiplication symbol in New Zealand. In the rest of the world, it looks like that.
That just looks so weird.
Yes. They use that for multiply. This is the variable.
It does look like Moscow.
Okay? Just notation differences.
We do x's like that.
Yeah.
Right.
Is that kind of multiplication and then x?
Exactly. Anyway, yeah. Okay. So that's the multiplication one. Okay. Yeah, they would write this as this curvy x business. All right. So it looks nicer. Everything looks nicer if that's the way you're used to doing it. Okay, so then I'm going to multiply those together and get what, guys? 120. So now I'm going to just start listing things that that multiply to give you 120 until I find the two that combine to make what? Negative 14. You watch those signs, please. So 1 and 120. Will that do it? No. 2 goes into it 60 times. Will they combine to make 14? No. 3 goes into it 40 times. Will they make 14? No. 4 goes into it. What? Oh, y'all are lazier than me. 30 times. No. 5 goes into it. No. You guys. 5 goes into 12 twice. No, 24. Oh, you guys. Yes. Going through every possibility until I get there. 6 goes in there how many times? 20. And it's not always 6. And 20 minus 6 will do it, right?
Yeah.
Okay, if it's a I'm sorry, whoops, be careful. Negative 20, positive 6, because I want them to combine to give me a negative 14, right? So 15x squared won't change. I no longer have negative 14x. I'm going to replace it with these two. So positive 6x's minus 20x's minus 8. Now I don't need the equal 0 thing because I'm still factorizing, right? I'm not solving. Still factorizing, so it might just be clutter. What's common to the first two? 15 and 6 will both divide by 3. X and x will divide by x. 15x squared divided by 3x is 5x. Positive 6x divided by positive 3x is positive 2, because the x's will divide away, yes? Okay. Bring down that minus. Don't ever lose that sign. 20x and 8 will both divide by 4. So I'm going to divide by negative 4. So negative 20x, divide out negative 4, you're left with? And if those two numbers don't match, you've made a mistake, right? And negative 8 divided by negative 4 is positive 2. Do the brackets match? And they have to. So that's 5x plus 2 in the first one times what in the second one?
3x minus 4.
And now we need to put it back in equals 0. Because now now where the factorizing is done, we still need to finish solving it.
So let's say it's still 8.
This is what you do to find parameters, right?
Yes.
Okay.
Okay. Now I'm just going to take each one. I'm going to take each one of those factors and set each factor equal to what? 0. So I've got 5x plus 2. Guys. I'm an old man. Come on. All right. So now we no longer have one quadratic but two linear. So we solve them by doing the opposite. So first thing, we're going to get the x term by itself by subtracting the 2. And then, because the x is multiplied by the 5, the opposite of multiply is divide. So our first answer is negative 2 over 3. Oh, over 5, sorry. I don't know. How do I know where these numbers come from? Okay, thank you. Good eyes. I was doing that on purpose to see if you're paying attention. All right. The next one's going to be over 3. So add 4 to both sides to get the x term by itself. Divide both sides by 3 gives you x equals 4 over 3. And those are my two solutions. And I expected 2 because I started off with a quadratic. Okay, so what we're going to do is we're going to walk through this problem. And I'm going to remind you, I don't know if I've ever shown you this before, the way I made it through graduate school with my little list on the side. So first, I know this is an equation because it has an equal symbol, right? So if you know that you're going to have to train yourself to ask each question, right? Because there are a lot of processes going on here. Then when you're working these, write the steps off to the side, right? Until you get it. Then you don't have to anymore, probably. Okay? And then I need to know, so I need to always do not parentheses, brackets first, right? For any equation, it's always brackets first. Do you have brackets? Yes. But I need to see if these brackets mean that they've already done some of the work for me, or do I need to get rid of them? And the key to doing that is seeing what it equals. And what does this one equal? So, have they done work for me, or do they just given me extra work to do? Extra work to do. Because if they had done the work for me, that would be the brackets equal what? 0. So, do you see the difference? Okay, so that's how you know that. So, first thing I need to do is get rid of the brackets. So let's expand. We'll first take x times x, which is x squared. We'll take x times negative 8, which is negative 8x. We're done with the x. Now we'll take negative 3 times our x, which is negative 3x's. And negative 3 times negative 8, which is positive 24. And it's still an equation that equals 84. Don't lose any bits as you go. Okay? Now, there is not enough room in the world on this problem. They don't give you enough room in the book for these problems, by the way. So don't think that because they give you 3 lines, it should take you 3 lines. Not going to happen. All right. Next step. Combine any like terms that are on the same side, right? and just abbreviate whatever you need to do, but write it out off the side until you really, 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 really know each thing to do. Because you don't want to get to the test and go, okay, I think I know that's what's next, right? You need to know definitively this is what I should do next. So x squared, the two x terms in the middle will combine to make negative 11x's, plus 24 still equals 84. Now, the next thing, I forgot fractions, but we didn't have any, so didn't have to worry about it. The next thing is, I need to know what kind of equation is it. So what kind of equation is this? Quadratic. Why? Exponent 2. Good. Exponent 2, so that means quadratic. Okay? Get used to identifying what it is you're looking at, because that's how you'll know what process to use. And to solve these quadratics, we're going to solve them by factorizing. So the first step is to set it equal to what?
0.
Does it equal 0 right now? No, it equals 84. So I need to move that 84 to the other side. Well, to turn an 84 into a 0, I'm going to simply subtract it from itself. Right? That's how you turn any number into 0, isn't it? So I'll subtract 84. But if I subtract 84 from that side, what? Subtract it from the other side. So get x squared minus 11x's minus 60 equals 0. If I did the math right, which is surprising sometimes. All right. After I have it set equal to 0, the next thing is to factor completely or factorize completely. I'm going to pretend that I'm abbreviating factorize as factor. All right, factor it completely. So first I'll look for a what? GCF or HCF. There you go. Is there anything common to x squared, negative 11x, and negative 60? No. How many terms? 3 terms. 3 uses the AC method, right? So first multiply a times c. So, but my a in this case is a 1, isn't it? So when I multiply my a times my c, 1 times negative 60, I'm going to get negative 60. So this is that one that's going to be kind of a shortcut. But if you don't recognize the shortcut, don't worry about it. The long way always gets you there. Okay. So think of things combined that will multiply to make negative 60, but combine to make 11x. Well, 1 and 60 won't do it, right? 2 and 30 won't do it. 3 and 20 won't do it. 4 goes into it, what, 15 times? Well, 4 and 15, they won't add to make 11, but will they subtract to make 11? Yes. And I want a negative 11, so that means I need my 15, the bigger one, to be negative. Yeah? Okay? Don't just jump around in your head. Write it out. It's not going to take you that much longer. And would you rather get the correct answer, or would you rather do it fast? Okay. So, now, x squared plus 4x minus 15x minus 60. And we don't need the equal 0 right now because we're still factorizing. Break it in half. What's common to the first two?
X.
So that dividing it out gives you x plus 4. Bring down the sign of the third term, which in this case is the negative. 15 and 60 will both divide by 15, which will divide that out. It's going to give us x plus 4. Do the brackets match? Yes, and they have to. Okay. So that means I have x plus 4 in the first bracket and x minus 15 in the second one. And now I'm going to put back the equal 0 because we're going to solve it now. I took it off to the side. I didn't need the x plus 0, the equal 0 part because I was factorizing. But now once you have it factorized, then you need the equal 0 part. Now what am I going to do? Set each one of them equal to 0, which creates not one quadratic, but 2 linear, which I just solved by doing the opposite. So this first one's going to give me x equals negative 4. The second one's going to give me x equals positive 15, because I would have subtracted 4 from both sides, and I would have added 15, and those are my 2 solutions.
How do we need to do all that in like 3 lines?
I don't know. It's ridiculous. Yes. Okay. Let's look at one that has the fraction in it. So We know that it's an equation because of the equal symbol. There are certain steps common to all equations, 3 of them. First thing you look for are brackets. Do you have any brackets? We're doing number 6 here. Do you have any brackets? No. What do you look for next? Fractions. Do you have any fractions? Yes. In order to eliminate the fractions from an equation, I simply need to multiply every term by the LCD, or which in this case there is only one denominator, right? What is the LCD or the denominator here? X. So I need to multiply this side by x, and since that is all one term, because it's one fraction, that makes it one term, I'll just multiply that one thing by x. On this side, x times another x is going to make what? Good. And on this side, these x's are going to divide away, so the denominator is gone, which is the point, right? And so all I'm left with is the numerator. Because when you multiply, because I'm multiplying x times 36 minus 5x over x. And remember, anything that's, when you multiply, basically what effectively is a whole number times a fraction, you just divide it. So if that's the same, it'll always divide away. So if you had like 6 minus x over 9, and you multiplied by 9, those 9s would just divide away. And it should divide away. If it doesn't, then you've picked the wrong denominator, right? That's the whole point, is to use that specific number so that it will divide away. Okay? All right.
Times the x by 36.
Because 36 minus 5x all over x is one thing. This is one term.
I thought terms had to be were always separated by
Pluses and minuses. Yeah, so if you had a plus 2, now it's 2 terms. But remember that a fraction is one term. It could have all of this over 2x squared plus 8x minus 25. That's still one term. Doesn't matter how big the fraction is. Every fraction is one single term. Okay? No matter how big or how small. Good question. Okay? All right. So unless you see a plus or a minus, then it's not a new term. So what if I had 2x over 3 plus 4 over x? How many terms is that? 2, right? Because there's a plus separating those 2 fractions. But if you have 2x plus 4 all over 3, the fraction bar extends over through the whole thing, right? So that's one term.
So for that, you would just do put the 3 out and then 3 times 4.
Yep. And they would divide away and leave you x plus 4. Mm-hmm. But again, you can only do that when it's an equation, and I didn't have the rest of an equation there, but yes, that's the process if it were an equation. Okay? All right. So now that we've eliminated the fractions, what's the third and final step for cleaning up an equation? Combine like terms that are on the same side. On this side, all I have is x squared, so no like terms. On this side, 36 and 5x, ladies, are not like terms, so I can't combine those, right? Now I'm ready, because I've cleaned it up using those 3 steps. Doesn't matter what kind of equation, you always start there. Then I need to know what kind of equation it is. What is it? What kind? Quadratic. How can I tell that it's quadratic? Highest exponent is a 2. Good. So we go to our process for solving it. We're going to solve it by factorizing. To solve by factorizing, the first step is to set it equal to 0. Now, I could move that x squared over with the rest of this stuff. But in order to do that, I would have to subtract it because it's a positive, and I don't ever like that thing to be negative. I'm going to move it anyway because I'm going to show you a little trick that you should be familiar with. All right? Now, it's not really a trick. It happens all the time. So if I subtracted x squared from both sides, that's going to give me my 0 on the wrong side. Does that matter? Nope, I don't care. If it says 0 equals and equals 0 mean exactly the same thing. When I get over here, I want these to be in descending order because in order to factorize them, they need to be in order. So the negative x squared is going to come first. The negative 5x would be next. And then a positive 36 would follow. The squared term, the x term, then the number term. Descending order from highest exponent down to no exponent at all, right? So x squared, x, and a number. Okay? They need to be that way in order to factorize them. That's one of the parts of the process of factorizing. But what is up there that I do not like at all, do you think? Negative x squared. That makes your life miserable when you're trying to solve it. But remember, I can do anything I want to an equation as long as I do it equally. So if I don't like a sign, I can change it. But if I change one sign, change them all. Okay? Yes?
Could you just, from the beginning, put the x squared on one side and subtract 36?
Yeah, but I'm lazy. I would subtract one thing before I subtract two things. But yes, absolutely. I just wanted to show you this. So if I don't like the sign, what? Change it. But if I change one, then I'd have to change what? All of them. So 0 doesn't have a sign, so who cares? So negative x squared becomes positive x squared. Negative 5x becomes positive 5x. Positive 36 becomes negative 36. And there now we don't have a negative x squared. Now again, remember, the equal symbol is the reason I can do that. So if I didn't have that equal symbol, if I was just factorizing something, could I just change all the signs? No. The equal symbol allows you, it's like a get out of jail free card. You can do anything you want to, but you got to do it equally. Okay? Now that I have it set equal to 0, next thing I'm going to do is factorize it. So that's 3 terms. There's no GCF or HCF. Sorry, I'll learn. All right, then, so it's going to be 1 times negative 36, which is negative 36. The two factors of negative 36 are going to combine to make positive 5 is what I'm looking for, right? So 1 and 36, they won't add or subtract to make 5. 2 and 18 will not add or subtract to make 5. 3 and 12 will not add or subtract to make 5. 4 and 9 will not add to make 5, but they will. And what kind of 5 do I want? Positive, which means my 9 needs to be the positive and the 4 needs to be the negative. Okay? Always check to make sure that they still multiply to give you your original. Does negative times a positive give you negative 36? Yes. So sometimes you can get numbers that will make this number, but they won't make this one. They'll give you the wrong sign. So be careful. Make sure you check your signs every direction. So now that I have the numbers, I'm going to simply replace that term, that positive 5x, with negative 4x and positive 9x. Remember to put your x's back in. Could I have reversed those two numbers? Absolutely. It's a foolproof method. So if you had put 9x minus 4x, as long as you get the signs right, the order of them doesn't matter. Okay? What's common to the first two? X. So divide out an x, I get an x minus 4. Drop down your plus. What's common to 9x and 36? They both divide by 9. Okay? Remember, here's your clue. You need this positive 9x to turn into an x. The only way to do that is divide out a 9, right? So even if your multiplication table skills are not superb, you can still do it. So we get x minus 4. Do the brackets match?
Yeah.
Yep. So I get x minus 4 times what? X plus 9. And it still equals what? 0. Now I'm going to put the equal 0 back because now I'm finished factorizing. I'm now starting to solve again. We're going to set each one of those equal to
0.
And again, you do not have to show this if you do not want to. Unless it's one of those questions where they ask you to write out the next step, right? So be careful. The first one, we're just going to add 4, which is going to give me x equals 4. Second, we're going to subtract 9, which gives me x equals negative 9. And those are my two solutions. Oh, factoring is going to be your friend by the time you leave this course, yeah? Okay. All right. Let's just scroll through the others and see if there's anything else odd. So let's look at it. So the first factor is 1/2 x. So I'm just going to set that equal to 0. The second one is x minus 2/3. So I'm just going to set that equal to 0. And then it's just two linear equations. And before I solve them, I'm going to eliminate the fractions. Right? So you can have, this is very odd. This would never happen to you if you factored it yourself because you will never factor anything and get a fraction in it. right? But they factored it for you. So we're just going to multiply both sides, in this case, by 2. So the 2's will divide away. It gives you x equals 0, which is nice because there's nothing else to do, is there? I multiplied these by 0. The 2's divided away. Gives you 1x, which is the same as plain old x. And 2 times 0 is still 0, isn't it? On this side, however, I'm going to multiply by 3. How many terms do I have over here? 1, 2, 3. So I need to multiply all that stuff by 3. So 3 times the x. Why am I using 3?
It's the LCD.
Yeah, it's the LCD. It's the only denominator too. Yeah. So that gives me 3x minus, the 3's divide away, you get 2. 3 times 0 is still 3. Right? So you get a linear equation. Add the 2 to both sides. Gives you 3x equals 2. Divide by 3.
3x equals 2.
Okay, I'm sorry, 2. I'm sorry, I said 3, didn't I? So we end up with x equals 2 over 3.
Wait, what? I thought you told me to multiply everything.
We did.
But you told me to multiply the 0 by 3.
And what do you get when you multiply times? It's all right. It's all good. Okay? Take it slow. All right. Okay?